So first of all, I will have to divide both sides by 3. So this is e to 5x equals 5, 5, and 7. And can anyone tell us what to do next? After we simplify both sides and we divide both sides by 3, we have to apply natural log. Very good. So this is 5x equals natural log 5, 5, 7. And we divide by 5. X equals natural log of 557 divided by 5. So this we have to put in the graphing calculator. We can't do this by hand. So y equals, not y equals, just natural log 557. Close the parenthesis and divide everything by 5. So we get, I don't know how many decimal digits they want, or just the exact answer. I have no idea. So approximately 1.26. I can go back and see what they say. Use a comma to separate answers as needed. Simplify your answer using integers or fractions for any numbers in the equation. Using a, okay, so they don't want us to plug in the number. So they only want natural log of 557 over 4. Any questions on this problem? Is this okay?
You said 557 over 4.
Over 5.
Oh, okay.
I probably said 4. I'm sorry. That's not what I meant. Okay, and is this okay, everyone? Any questions? And the other question, let's take a look. It's the same thing. It's the same type of problem. 17 to x equals 137. So we don't have anything to do here other than applying natural log. So x times natural log of 17 equals natural log of 137. So x equals natural log of 137 over natural log of 17. Now let's see what they want. Use integers or fractions for any numbers in the expression. Use natural log for logarithm. So they don't want an approximation. So they just want the exact answer. Any questions?
I do, but it's kind of weird.
It's okay.
All right. So log is common logarithm, correct? LOG.
LOG is common and LN is natural.
Well, then why isn't it NL if it's natural log?
Excellent question.
LN
Because it comes from German.
Okay.
We should have had it as natural log, right? NL. It comes from German.
Okay.
Yeah, very good question. Okay, anything else? Do we have anything else? Yes.
I have a question about
Yes.
the first example.
Yes.
Because in the second one you have the natural log on the numerator and the denominator.
Right, but natural log E, we know it's E. It's 1. So I should have written here natural log E, but that since it's 1, I omitted it. Yes, very good point. Good. Anything else? Is there anything else? Very good. So let's continue then with 6.1. And that is Gauss-Jordan method. And we're only going to look at 3 by 3, meaning 3 equations and 3 variables. The method can be used for any amount, any number of equations and variables. We're fine if we just look at the 3 by 3. 3 equations, 3 variables. However, before we address this, there is a lot of details that we have to work through. Here is, I'm going to copy a system. We're going to work, I'm going to explain what we need to before, or the preparation before we apply the method called Gauss-Jordan. What is this method? A third method. We know substitution, we know elimination. This is a third method, which is going to look different. It's not really entirely different. Okay. One thing that I would like to mention here is when we solved systems of two linear equations in two variables by elimination. What did we do? We multiplied one equation by 4, and we added the result to the second one, correct? Did we do that several times? Okay, let's go back and just make sure that this is clear, because I need this for later. Where am I? Here. Okay. I need this, and please remember what we did. For example, let me find one. Yes, here it is. In this example, we multiplied the second equation by -2. And after we did this, we added them and we got this equation. So please keep this procedure in mind, because I'm going to list it in a minute. And you'll see why and how. Okay, ready? So I'm going to copy system. Let's look at, let's say, 21 on 631. Here's the system. X plus y minus z equals -2. 2x minus y plus z equals 5. And -x plus 2y plus 2z equals 1. One thing that a student asked me in the previous class, and I want to mention it right now. If you decide to use Gaussian elimination, which is only half of this method, I'm fine with it. If you say, well, I know Gaussian elimination and I find it easier, I'm fine. So if the problem is asking you to use Gauss-Jordan, and I will ask you to use Gauss-Jordan, and you write me a note on the side, say, I'm very comfortable with Gaussian elimination, go for it. You'll get full credit. However, this is the method that I think is more important than Gaussian elimination, and I think it's more work with Gaussian elimination, but a student asked me, and I said, why not? If you're happy with Gaussian elimination, not Gauss-Jordan, I'm fine. So keep that in mind. Okay, so here are the preps. In order to solve the system using Gauss-Jordan method, we have several preps, several details to look at. Here's the first detail. The matrix of coefficients. And I want to warn you, of course, the first problem we look at is going to take forever. So what are we trying to do? We are trying to find the ordered pair, because it's good to give you the heads up. I learned that from Ella, and she's completely right. I also want to see where are we going. So I want to determine x, y, and z. This is our target. But the method is, before we, complete one problem, it may, look difficult. Okay, so the matrix of coefficients, or the coefficient matrix. First of all, what is this word? What does it mean? It means an array of numbers. That's what a matrix is, an array of numbers. What are the coefficients? Of course, 1, 2, -1, 1, -1, 2, -1, 1, 2. These are the coefficients. So then the matrix is denoted by uppercase A. We use two huge brackets. We're not talking about interval notation or anything like that. And I will copy the coefficients. 1, 2, -1. 1, -1, 2. -1, 1, and 2. Exactly as we have them in the system. That's prep number 1. Now prep number 2 is something called the augmented matrix. You can say, what is that? In a second, you'll see. The augmented matrix. Well, it has something extra. It's the same matrix, but with something extra. So what is it? So here's the notation for the augmented matrix. Uppercase A, a vertical bar, and a lowercase b. And you'll see in a moment what this means. Of course, it has to have the same bar, vertical bar. in the left of the bar, vertical bar, I have 1, 2, -1, 1, -1, 2, -1, 1, and 2. The same thing I had before. But now it's augmented, and it's augmented with this little b. But this little b stands for the free terms, -2, 5, 1. So now let's look at this augmented matrix and realize what it means. Here's what it means. X plus y minus z equals -2. 2x minus y plus z equals 5. It's a different representation of the system. Same thing. -x plus 2y plus 2z equals 5. Okay. What is my target? Here's my target. Apply 3 allowed operations. We call them row operations. Row operations. In order to get this. Give me 3 numbers that you can think of. Any 3 numbers you want. Excellent. I don't know if we're going to get to this, but I know for sure we're going to get to this. But if we do change the entire matrix using certain operations into this, can anyone identify X? 6. Can anyone identify Y? Or can anyone identify Z?
3.
That's it. But the question is, how do I get that matrix to look like this one? But if I do, I know that X is 6, Y is 4, and Z is 3 because everything else is 0. Everything else has coefficient 0, so it's gone. Okay, now let's list these 3 allowed operations. And let's see, of course, this is not the answer. I just made it up. I just wanted you to give me 3 numbers. But this would have meant 6, 4, 3 as the solution. But of course, this is just something we came up with. Ready? So 3 allowed row operations. Only these 3 and nothing else. Ready? Operation number 1. Swap rows. Question is, why would I want to swap rows? You will have to wait and see. But here's my question to you. Let's suppose I want to make this row to be the first row, or this equation to be the first equation, and make this equation be the second one. In other words, swap these 2. My question is, do you think that the final solution will be different? This is like telling you, I have this marker in my left pocket and I want to move it to my left, from my right to my left. Of course, nothing changes, right? I'm still solving the same system. Regardless of the order I write the equations in, it's the same system. Good? So that was the first step, or first allowed row operation. Here's number 2. Second row operation is multiply or divide by definitely a non-zero number any row. And you could say, wait a minute. We did that. We multiplied both sides of this row by -2. It's not a 0 number. I cannot multiply by 0. So I was allowed to multiply or divide both sides by 100. Same thing, right? So all these rows are equations, right? So we're allowed to multiply or divide both sides by a non-zero number. And here is the third possible or allowed row operation. Ready? The first one that we looked at 10 minutes ago. Multiply any row by a non-zero number and immediately add that row to another equation. One more time. Here it is. We multiply this row by -2. Here it is. And we added this row to the first equation to get the third one. So that's what we're going to put in writing. Multiply any row by a non-zero number and add the result to another row of our choice, of course. If we have reason to do that, of course. You see in a moment. And add the result to another row. Okay, I'll copy the augmented matrix again. So here it is. 1, 2, -1, 1, -1, 2, -1, 1, 2, -2, 5, 1. Matrices are not equal. You cannot put the equal symbol between these matrices. You can only draw an arrow between them. Before we start, I should have written this before, right, but that's okay. Here is the sequence of steps from which we can never deviate. Sequence of steps. If we deviate from the sequence of steps, we will never get the solution. So here it is. And this is whatever, whatever, and whatever. Step number 1, we have to have a 1 in the first row, first column. With this 1, we will obtain the corresponding zeros. The next step, we will obtain the 1 in the middle, and then the corresponding zeros. Final step, we will obtain the 1 in the third column, and then the corresponding zeros. One more time, no one can change this sequence. One more time. 1 and the corresponding zeros. 1 and the corresponding zeros. 1 and the corresponding zeros. One more time. 1 and the corresponding zeros. 1 and the corresponding zeros. And 1 and the corresponding zeros. This is our sequence. We have to follow it to the T. We can't change any of that. Okay, well, I'm lucky and I'm happy. I already got this. It's already there. By chance, it's 1. So therefore, I'm here now. I want to obtain 0, and I want to obtain 0. I will have to multiply row 1 by something. On the side, I write every step I perform. Row 1 will be multiplied by something and added to row 2 to eliminate 2, and I'll ask you what, by what. And then row 1 multiplied by something else, it could be the same, it may happen, and added to row 3. So let's do this together. What do I multiply 1 by to add it to 2 so that I get 0 here? Excellent. What do I multiply 1 by to add it to -1 and get 0 here?
1.
Excellent. So let's write the next step. Arrow, not equal symbol. Which row do I have to copy because I know it does not change? Exactly. 1, 1, -1, -2, because that's carved in stone for now. So let's do this together, please. 1 times -2 plus 2. Excellent. 1 times -2 minus 1. -1 times -2 2 plus 1. Excellent. Negative 2 minus 2. Negative 2 times negative 2. 4. 4 plus 5.
9.
Let's do this step one more time. Yes?
Okay,
Elsa, go ahead.
It's basically what you're about to do, but you multiplied the first row.
I multiplied the entire first row by negative 2 and add to the corresponding terms because this represents y and this represents x and this represents z and this represents the free term. So one more time. 1 times negative 2 plus 2 is 0. 1 times negative 2 minus 1 is negative 3. Negative 1 times negative 2 is 2 plus 1 is 3. Negative 2 times negative 2 is 4 plus 5 is 9. Now we're working on row 3. 1 times 1 minus 1. It better be, right? Okay. 1 times 1 but plus 2 now. Excellent. Negative 1 times 1 but plus 2. Negative 1 times 1 is negative 1. Negative 1 plus 2 is 1. Negative 2 times 1 plus 1.
Negative 1.
That's it. Here's what we accomplished. And no one can change that. If the next step changes the first column, we are in big trouble. Good. What would be my next step? I accomplished, yes?
So for that one, you multiplied the first row by the 1.
You mean for the next step?
The one that you just did.
Oh, okay. Yeah, you mean for the third row?
Yeah,
By 1.
by 1. And you added which corresponds.
So I multiply the entire row and add to the corresponding ones. 1 times 1 minus this. 1 times 1 plus this. Negative 1 times 1 plus this. Negative 2 times 1 plus this. It's the same. It looks differently because we are already coming up with a third equation without writing it, basically. Okay. Yes.
Real quick,
Yes.
can you get the numbers for the row 1, like the negative 2?
This one?
Yeah.
What do I multiply 1 by?
Using it zeros.
Better?
Yeah.
Perfect.
Okay.
That's okay. That's okay. Yeah, it's the first example. You know, you're entitled to any questions and any time anyway. So, good. Moving on. Here's my target next. What do I want to have there? I want to have a 1. Very good. Is there a way of doing something to this row and maybe getting a 1 in there? Negative 3. Very good. Row 2 divided by negative 3. Excellent. So let's copy everything. The top row does not change. Give me the second one, please.
0.
Yes.
0. No, 1.
1. Perfect.
Negative 7.
9 divided by negative 3 is negative 3. So 0, 3, 1, and negative 1. This is done, and also this is done. Now my target is this. My next step. Getting a 0 instead of a 1 and getting a 0 instead of a 3. Okay. Which row do I have to use now? I have no choice. In the first step, I used row 1. What do you think I'm going to use now? Of course, because this will help me get 0 here, and this number will help me get 0 here. So it's R2 times something to R1 and added to R1, and R2 times something and added to R3. Of course. Very good. Now let's see what we need. What do I multiply 1 by to eliminate this one? Perfect. What do I multiply this to eliminate this? Excellent. Which row do I copy now which I know it's not going to change at this moment.
The first row.
Not the first row, no. I'm not using it. It's the one that I'm using it that does not change. Exactly, the second one. 0, 1, -1, -3, and 1, 0. This cannot change. If this is broken, then I'm going backwards and I'm never going to solve. Ready? 1 times -1 plus 1. Perfect. -1 times -1 minus 1. Lucky me. -3 times -1. 3 minus 2. Excellent. 1 times -3 plus 3. Excellent. -1 times -3 plus 1. Excellent. -3 times -3. 9 minus 1. Excellent. Done. Where is my next step? And it cannot be anything else. Yes, I want this spot to be a 1. Is there anything I can do to both sides to get a 1 here? Exactly. Row 3 divided by 4. Excellent. Yes.
You're trying to get a 1 where?
I'm here. I'm here. I'm done this with this. I'm done with this, and I have to be on the last step. Better? Perfect. So I have 1, 0, 0, 1, 0, 1, -1, -3, 0, 0, and please tell me what to write. 1 and? Careful. 4 divided by 4 is 1. 8 divided by 4, 2. Very good. Okay. All this is done. And even this. Lucky us. Which row do I have to use now? I used row 1, then I use row 2. I have to use row 3 because that's where the 1 is. So this time is only a row 3 multiplied by something and added to row 2. What do I multiply this row by to add it here and eliminate this and change this into a 0? Only this one. I multiply this row to get a 0 here. By what? 1. Very good. Final step. 1, 0, 0, 1, 0, 0, 1, 0, 1, and 2. 1 times 1 minus 1. Perfect. 2 times 1 minus 3. That's it. We hope, we don't know for sure. It's so easy to make a mistake with this method. So we hope that the solution is go back to the original system. Replace 1, -1, 2. Like 15 pages later, earlier. Yeah, that's what it is for the first method. For the first problem, I have a lot to say. 1, -1, 2. 1, -1, 2. 1, -1, 2. 1, -1, 2. Let's try. 1 minus 1 is 0. -2 equals -2. Yes. 2 plus 1 is 3 plus 2 is 5. Yes. -1 minus 2 is -3. -3 plus 4 is 1. Yes. Only now I can say indeed. Yes. And this is Gauss-Jordan. It's the first problem.
I don't like this.
Good. So let's look at another problem. Ready? Let's look at 26. Same page. 26. X minus 3z equals -2. 2x plus 2y plus z equals 4. 3x plus y minus 2z equals 5. It's like a puzzle. Look at it as a puzzle. Okay, ready?
Did I start this?
Yes, I did. Okay, so can anyone give us the augmented matrix?
Is it 1 at the top?
Yes.
Mhm.
So
Is it
1,
0?
1, 0, negative 3, negative 2. Very good.
Then 2,
Yes,
2,
yes,
1,
yes,
4,
yes,
3,
yes.
1, negative 2, and 5.
That's it. We are lucky again. 1 is there. But I want to remove the 2 and the 3. Which row do I have to use? Of course, where the 1 is. So R1 times something plus R2, R1 times plus something times plus R3. On the side, we have to write what we're trying to do. Which row do I copy? Because I'm using it and it can change. While I'm using it, it cannot change. It's row,
The first one.
the first one. Very good. 1, 0, negative 3, negative 2. Perfect. So what do we multiply 1 by to edit here and eliminate 2?
Pause for this 1 second.
Say it again.
I just gotta catch up right.
Sure.
You great.
So what do we multiply by?
Negative 2.
Do we agree with negative 2? Everyone?
Yeah.
Yes? Okay, negative 2. What do we multiply by to eliminate the 3?
It's bad.
Do you all agree with negative 3?
Yeah.
Is everyone caught up? Any questions? Any questions? Yes, Rachel?
Since we're working on the first row,
We're working with the first row to eliminate the 2 and the 3.
so that one can't change. That's why I've only wrote down.
Correct. Yes. The row I'm using has to stay for now. Maybe later on will change, and of course it will, but at this point in time, while I'm using it, it cannot change. So 1 times negative 2 plus 2.
0.
0 times negative 2 is 0 plus 2,
2.
2. Negative 3 times negative 2
6.
plus 1.
7.
Negative 2 times negative 2
4.
plus 4.
8.
That's it. Any questions on 0, 2, 7, 8? Okay, please dictate the next step, and I'll write it. And don't say 100 because I'm not going to write 100. So 1 times negative 3 plus 3. Of course. 0 times negative 3. 0 plus 1.
1.
Excellent. Negative 3 times negative 3.
9.
9 minus 2.
7.
Excellent. Negative 2 times negative 3. 6 plus 5.
11.
11. This is what we accomplished. Is this clear? Are these 2 steps clear?
So you just, this, what you just did,
Yes?
you multiplied the first row
Mhm.
by negative 3.
By negative 2, and I added to the corresponding in the row 2.
Yeah.
And then by negative 3, and I added to the corresponding in row 3.
What was the, can you point out the corresponding? I'm getting lost.
This corresponds to this, this corresponds to this, this corresponds to this, this corresponds to this. This corresponds to this. They're all x values. This corresponds to y, this corresponds to y, this corresponds to z, this corresponds to z. So when I multiply by negative 3, 1 times negative 3 goes here. 0 times negative 3 it goes here. And negative 3 times negative 3 and it goes here because I'm using the z. And it has to end up with a z. I cannot edit here.
Mm-hmm.
So when I multiply the first row by negative 3, Negative 3 times 1 plus this will be 0. Negative 3 times 0 plus 1 will be a number. Negative 3 times this plus this number will give us something else. And this times this plus 5 will give us something else. It's just a second problem. So, you know, you're going to get better. Good. Where is my target now? Yes, right here. And what do I want in here? A 1. Is there an easier way of getting a 1 in there? Yes, swapping the second row with the third. However, I cannot touch the first one because if I swap the first one, I will no longer have the 1 up here. So that one is carved in stone, but these two are 0, it's okay. So I'm going to say row 2 becomes row 3, and row 3 becomes row 2. I write on the side every step we make. So can anyone dictate other than 1, 0, negative 3, negative 2? Can anyone tell us the new second row? 11. Very good. And then row 3 will be now 0, 2, 7, and 8. So we are happy. This is done, and this is the 1. I'm also happy that this is a 0. So I'm only focusing on this now. Which row I have to use in order to get the 0 instead of a 2. The second row, of course. The second row, multiply by something and add it to row 3. What do I multiply this number by to add it here and get a 0?
Multiply to get a 0. Is it negative? No. No, yeah. Is it negative 2?
Perfect. Negative 2 indeed. Which rows do I copy? Definitely row 2. But there is one other row that will not change because it already has a 0 at the top. So 1 and 2. 1, 0, negative 3, negative 2. 0, 1, 7, 11. Of course 0 because this cannot change. So let's do this together when you're ready. 1 times negative 2 plus 2. Perfect. 7 times negative 2 plus 7. Excellent. 11 times negative 2.
Negative 22.
Negative 22 plus 8.
Negative.
Very good. What did we accomplish? All this is done. Where is my target next? I'm done with the first row. I'm done with the second row. Obviously, I'm working on the third one. But this is not done. I need, what do I need in here? Good. So then I will divide row 3 by, of course, negative 7. I copy 1, 0, negative 3, negative 2. I copy 0, 1, 7, 11. I copy 0, 0, and then I'll wait for you to tell me what to write. 1, and what else? I cannot just divide one side and not the other side of the equation. Negative 14 over negative 7, 2. So now this is done. Can anyone give us already z?
Is it 1? I mean, 2.
Indeed, z is already 2. But we don't have to worry about it just yet because we have one more step. Now the target is here. I want a 0 and I want a 0. Which row do I have to use? And I have no choice. I use row 1, it's done. I use row 2, it's done. So I'm at here at the 1, so I know exactly which row. Yes. It has to be row 3 multiplied by something and added to row 1, and row 3 multiplied by something and added to row 2. Very good. Please tell me, what do you multiply row 3 by, forgive me, to eliminate negative 3? Indeed. Awesome. What do you multiply row 3 by to eliminate the 7? Negative 7. Excellent. Last step. Well done. Of course, I copy 1, 0, 0, 1, 0, 0, 1, and 2. Those will not change. If they do, we're going backwards and we'll never solve. One times 3 minus 3. Excellent. 2 times 3 minus 2. Excellent. 1 times negative 7 plus 7. 2 times negative 7 plus 11. And I'm still not certain. But what do you expect the solution to be? With a big question mark. I have no idea. I have to go back to my problem, back to the original system, and replace 4, negative 3, 2. 4, negative 3, 2. 4, negative 3, 2. 4, negative 3, 2. This is 0 here. 4 minus 6. Check. 8 minus 6 is 2. 2 plus 2 is 4. Check. 12 minus 3 is 9. 9 minus 4 is 5. Check. No doubt. It's a yes. It looks difficult at first, but if you practice with 4 problems, again, if you read your book and you consider that Gaussian elimination is easier for you, use it.
So that one was the Gauss-Jordan?
Gauss-Jordan. Gauss-Jordan. This is Gauss-Jordan. Now, if you want Gaussian elimination, in my opinion, is slightly more difficult. You will have to get the zeros here and then go back with substitution. Determine z and then plug it in and create a new system, plug in the z and plug in x, y and z and then determine x, going backwards. If that's easier for you, I'm fine. Whichever method you want to use. I think that this is the full method, and if you like, we can choose another problem, or if you say no, we'll start the last section. Sure, of course. So if you'd like to choose, but just choose the 3 by 3. Don't choose the 4 by 4. It's way too much work.
You said that we would be expecting like fractions as well.
No, I'm just saying we can. We never know what we get into, but we can. But not more than 3 by 3. What I'm saying is don't choose a 4 by 4. Rachel wants to choose, and I said don't choose a 4 by 4. Choose any problem that is a 3 by 3.
Are you saying you want to do a problem that may have a fraction?
Yeah, because last class you said that.
Yeah, we did. We did run into a problem that had fractions. Yeah, which is okay. So would you like to choose, or do you want me to choose, or do you have one in mind? I have no idea. You can choose anything you want. They're all the same, pretty much, I'm sure. 21 through 34.
Let's do 30.
Which one?
30.
30, very good. Let's do 30.
Okay.
631.
Thank you.
Okay, here's 30. 2x plus y equals z plus 1. 2x equals 1 plus 3y minus z. And x plus y plus z equals 4.
What is this called?
Gauss-Jordan.
Okay.
So I obviously see that this system is not arranged in the correct order. So in order for us to use Gauss-Jordan, all terms with x have to be one below the other, all terms with y, all terms with the z, equal symbol, and the free term on the right. So then I will rearrange the system, and I will write 2x plus y minus z equals 1. 2x minus 3y plus z equals 1. X plus y plus z equals 4. This is a mandatory step. After you're done, I'm waiting for you to give me the augmented matrix. Are you dictating on rows or columns?
Row.
Row, okay.
2, 1, negative 1, and 1.
Excellent.
2. Negative
1,
Excellent.
1.
1, 1, 4.
Very good. Where is our starting point? What do we have to do first?
Wow.
Yes, I will swap them. And I like this last row to be the first. Remember, the conditions can be rearranged in any order we like. It doesn't matter. The system would have the same solution.
So swap the last row to the first row.
Make the first row the last, and make the last the first. We write on the side every step we make. Row 1 becomes row 3, and row 3 becomes row 1.
And why are we doing that?
Because of the sequence of steps. We have to have a 1 at the top.
So one has to be at the top on that right hand side.
Yes.
Okay.
So we have 1, 1, 1, and 4. And we have 2, negative 3, 1, and 1. And we have 2, 1, negative 1, and 1. Is this clear so far? Okay. You understand that I can make a 1 in here by dividing both sides by 2. But
Yeah.
I don't really want to have fractions. So it's easier, and this is an allowed operation, row operation. We have 3, so I'm allowed to swap. Why not? So now this is done. Which row do I use? Yes, I have to use the first row. So the first row times something plus the second. The first row times something plus the third. Great job. So what now? Yes, negative 2. And for the other one? Indeed. Very good. Which row do I copy? I'm using it. It cannot change at the same time I'm using it. Right. 1, 1, 1, 4. I know, I repeat myself a lot, but you need that repetition. So, then it will come in easy. Good. So, 1 times negative 2 plus 2.
0.
Next one. 1 times negative 2 minus 3. Perfect. 1 times negative 2 plus 1.
Negative 1.
Excellent. 4 times negative 2
Negative 8.
plus 1.
Negative 7.
I really don't like this row, but it is what it is. 1 times negative 2 plus 2.
0.
Great job. 1 times negative 2 plus 1. Excellent. Not too bad. 1 times negative 2 minus 2.
You mean minus 1?
Of course. I'm sorry. 1 times negative 2 minus 1. Forgive me.
Negative 3.
Excellent. 4 times negative 2
Negative 8.
plus 1.
Negative 7.
Ah.
Oh, I guess that's too bad.
So this is accomplished. Not too bad, because now I can swap again to get the 1 and divide by negative 1. So I will swap these two. Row 2 becomes row 3. Row 2 becomes row 3, and row 3 becomes row 2.
And this is to get that 1.
To get that 1, because otherwise I will have to divide both sides by negative 5. And I will have 1/5 and 7/5.
Even if it's a negative 1?
I will divide by negative 1. That's not a problem. 1 and negative 1 are friendly.
I just wanted to.
Right, but
Make it
5, negative 5 is
Yeah.
not friendly.
Okay.
Unless these two are divisible by 5, but they're not. Is that clear?
Mhm.
Perfect. 1 and negative 1 can be easily fixed. So now I copy 1, 1, 1, and 4. And I copy 0, negative 1, negative 3, negative 7, and 0, negative 5, negative 1, negative 7. All I did was swap 2 and 3. So this is done. what we need to do next.
Divide by the negative.
Exactly. Very good. Row 2 divided by -1, or you can say, or row 2 times -1. Same thing. Perfect job. So we copy 1, 1, 1, and 4. And we copy 0, 1, 3, and 7. And we copy 0, -5, -1, -7. Are you with me?
Mm-hmm. For once.
I'm not.
You did very well.
So-
It's not for once. Yes.
When you say that where we're supposed to be with the 1, 0, 0, is that like what's supposed to, like, is that the step that's supposed to be right there?
The sequence.
This sequence?
So the sequence is we have to get the 1 and then the zeros, and now the 1 and then the zeros. And then the 1 and then the zeros. We have to get the 1 in order to form the zeros. If we don't get the 1 first, we will not be able to get the corresponding zeros. So now the next step. Which row do we have to use now? Row 2. Row 2 times something plus row 1. Row 2 times something plus row 3. What do I multiply the 1 to eliminate the 1 at the top? Correct. What do I multiply the 1 to get to eliminate the -5? Very good. Awesome. So let's take a look. Which row do I copy? Because I know for sure it's not going to change.
Is it one?
We're using row 2 now. We're way beyond row 1.
Oh.
We're using row 2. Once I'm using row 2 cannot change. I cannot multiply it and let it change at the same time, right?
Okay.
It's the next step. It's level 2 right now.
Okay.
So it has to be row 2 that cannot be touched. We are using it. So of course, and 1 and 0 have to stay. 1 times -1 plus 1.
0.
3 times -1 plus 1.
-2.
Excellent. 7 times -1 plus 4.
-3.
Excellent. Is this clear?
Just multiply by 2.
Yes. And now I multiply the same row, but by 5 this time, and I add it to row 3. 5 times 1 minus 5.
0.
Perfect. 3 times 5 minus 1.
14.
Excellent. 5 times 7. 35. 35 minus 7.
28.
Excellent. We accomplished this. Where are we now? And what are we trying to do?
We gotta get rid
That last
Of
column.
of last row.
Of 14. I need to get rid of 14. How do I get rid of 14? Dividing both sides of row 3 by 14.
So you can get 1.
Exactly. 1, 0, 0, 1, 0, 0, 1. So 14 divided by 14 is 1, and 28 divided by 14 is 2. Very good. Final step. In the final step, which row I have to use? Row 3. Multiply to add to row 1. Row 3 multiply to add to row 2. Okay. So I need to multiply 1 by something to eliminate -2. 2 indeed. I need to multiply 1 by something to eliminate 3. That's it. And this will be the last step. Tell me when you're ready for the last step. Which row do I copy, which will not change at this point? Exactly. And of course, what I already built. If I destroy what I already built, I'm going backwards and I'm not solving. Okay, very good. 1 times 2 minus 2. Perfect. 2 times 2 minus 3.
One,
Perfect. 1 times negative 3 plus 3.
0,
Excellent. 2 times negative 3 plus 7.
1,
Excellent. We hope, we have no clue. We hope that the solution is 1, 1, 2. Nobody knows though. One, 1, 2. Ready? Okay, let's take a look at 1, 1, 2. 1, 1, 2. 1, 1, 2. 1, 1, 2. 2 plus 1 is 3, minus 2 is 1. Check. 2 minus 3 is negative 1. Negative 1 plus 2. Check. 1 plus 1 plus 2. Check. Ah, yes.